Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, I'd like us to spend a little bit of time thinking about multiplication facts and helping your child learn the facts. Now, I want us to think about the difference between memorizing facts, which many of us did, which was memorizing the symbols, lots of symbols. You did flashcards and you got answers to those symbols, versus strategies. And what I hope you'll see is if we look at the strategies, we'll get the facts, but we'll also be able to do things mentally that go beyond the facts. Now, part of what I'd like us to think about is the order in which your child learns the facts. Some children have a very hard time memorizing all those symbols, those flashcards. You can do them for hours and they still struggle with it. So what we want to do is think about an order that will help them remember their facts. The other side of it is we want to build imagery that gives them something to link to the symbols. And as I said, once they get that imagery, it'll help them with the facts, but beyond the facts. So what I recommend you consider doing is we're going to start with the zeros, the ones, and then do the tens. Not do them in order, zeros up to tens, but do zeros, ones, and then tens. From the tens, we'll do the nines because we build down from the tens for those, and we do the fives because those are half of the tens. We'll then do doubles and use repeated doubling to do twos, fours, and eights. We'll look at square numbers because for many children, that square number and looking at squares and areas is easier for them to remember. And then throughout, we'll use the distributive property. So let's look at the zeros, ones, and tens. Now for zeros and ones, I had colleagues in Wisconsin remind me how important stories are for learning the zeros and the ones. Because if you do stories, understanding the facts, you don't have to memorize individual facts. You'll just know when you multiply by zero what happens. So think about, I could ask your child, or you ask your child, to draw a picture for 5 groups of 0 cookies. Now, they may look at you like, that's kind of weird. You're like, what? But have them draw it. You try to stay serious, and our goal is to get them giggling a bit about that. So they could draw 5 groups of 0 cookies, 7 groups of 0 cookies. And once they draw the picture, then we label it for them. Oh, so you had 7 groups of 0 cookies. So now they see the symbol 7 times 0. They think, oh, that's 7 groups of nothing. It could be 0 cookies, 7 boxes of 0 cars, toy cars, right? Or toys, blocks, whatever you want your story to be that's meaningful for your child, we use that. And then we can do 0 groups of 7 cookies. And then they will look at you like, what? Because the paper should be blank, right? If they draw a circle, now they've got 1 group. So it's 0 groups of 7. Stay serious, get them giggling. And once they do that, see, they start to realize 0 groups of anything, or however many you want of 0, is going to be 0. We do the same thing with the ones. 7 groups of 1 cookie. We label it for them so they can see the multiplication fact connected to the picture. We can do 1 group of 7 cookies. Now we want them to understand that the picture for 7 groups of 1 may look different than the picture for 1 group of 7. This will help them with story problems. We also want to know that the end result is the same, right? That's that turnaround commutative property. So the product in each case is going to be 7, but our picture may look a little different. Now, we start with the stories. The children draw the pictures for the stories. We then label the picture with the facts: 1 times 7, 7 times 1, 0 times 7. From that, we then start and we show them a fact. We might show them 7 times 0 and have them tell us a story. So we want that connection very strong both ways. And then from that, we'll be able to extend beyond the facts. They'll know their zeros and their ones, which are easy. They'll know it in a way, though, that takes them from just memorizing those 10 or 11 facts associated with it to being able to generalize out far beyond the facts. Then I said, let's do the tens. Now, one way to do the tens is through picture, and we do what we know is a high yield strategy. It works really well as quick images. So what happens is we flash an image at your child very quickly, and they tell us what they see. So, I mean, it's very fast. I'll do it with you. I'm going to show it in 3, 2, 1. Okay. So did you see how fast that was? Now, I do it that quickly because I'll show it again. And we want your child doing some risk taking, but they tell us what they think they saw. I'll show it again. 3, 2, 1. So I'm essentially doing as fast as it takes me to do a forward arrow and a back arrow. And they can test, predict what they saw, and then we can look at it. So I've got 6 groups of 10. Now, this is a familiar image to your children, to many of your children. These are 10 frames. They get to know that a filled frame is a 10. If you want to see more about this, there are other videos available, especially the intro to multiplication and the grade 3 multiplication video you can look at, and I'll leave links in the description below. But I've got 6 tens. Again, I can label it. I can talk about 6 tens. I can show the fact. Okay. I could also use a base 10 image, the base 10 blocks, which your child is familiar with, right? We use these rods of 10 by 10s later. Now, our 9s build down. Once they get the 10s, and those usually come very quickly, right? 6 tens is 60, 4 tens is 40, 8 tens is 80. Then we do the 9s, and I'm going to do it in a similar way. I'll show it in 3, 2, 1. And what we want them picturing is there's an empty space in each of those groups. So to find what 6 9s would be, well, I know 6 tens is 60, and then I removed one out of each group. So 60 minus 6, 54. Okay. Now, once we've got that, see, this is the distributive property. That's why it's working. We're thinking of 9 as 10 minus 1. So I can find 6 tens minus 6. And this strategy will help me with the facts. It might take a little longer. And the more your children work with the strategies and the facts, the more they remember the facts, not just memorizing them. We want them to remember them and be fluent with them. Now, I could do the same image with base 10, cross one out. Okay, same idea, still distributive property. For our 5s, if I flash this image in 3, 2, 1, notice what we're doing there. We're showing the 5s as half of the 10s. So if I know that 6 tens is 60, 6 5s is half of that, 30. Okay, so half of my 10s, I'm purposeful in the image because I want them to picture whenever you multiply by 5, multiply by 10, that's easy. And powers of 10, right? When we multiply by 100, 1000, we know there are patterns that occur with the zeros. So if I multiply by 50, I can multiply by 100 and take half. If I multiply by 500, I multiply by 1000 and take half. See, these strategies will help me far beyond the facts. Now, I can use the same idea with a base 10. For your children who have a hard time just memorizing straight facts, straight symbols, these are some of the strategies that can help them. We're linking imagery to the symbols to the fact. What's important, though, is if your child memorizes those symbols well, they know their facts, they learn them. These strategies are really important still for them, important for them to see because they'll be able to use them and do more mental multiplication with them if they know the strategies and have the related imagery. So it's not an either or, it's really a both. So thinking about half of that. Now, doubling is another strategy we use. And again, if you look at the intro to multiplication or the grade 3 multiplication, you'll see a bit more with doubling. If you go back to the grade 1 addition and the addition overview, you see that we do doubles as an addition strategy. So it's just linking that addition strategy to the multiplication. Notice the image is really important because I can double 8 by doubling 5 and doubling 3. If I want to do 4 8s, I double those 5s, I double the 3, and then essentially I double the 16, right? I double that 2 sets of 8. And that gives me 20 when I double the 10s, 12 when I double the 6s. So 4 8s can be thought of as double-double. Now, in other videos, we've looked at 4 8s using a distributive property approach, right? 4 8s, same as 4 5s put together with 4 3s, right? Bring that down. Now, I'm thinking of 8 as 5 and 3. I could think of it as 62, 6 and 2. So I have 4 6s put together with 4 2s. I can use that distributive property and build down like we did with the 9s. What's 4 8s? Well, it's 4 10s remove 4 sets of 2. So there are lots of options, all linked to strong imagery. So think about the repeated doubling. Double 8 is 16, and notice how I'm reading those symbols as double 8, not 2 times 8, right? I'm trying to connect language that'll help me with story problems, with imagery, to those symbols. So double 8 is 16. If I double it again, double 8 is 16, double 16 is 32. I could do 3 sets of 8, 3 factors of 8. Double 8 is 16, double 16 is 32, double 32 is 64. So that doubling, double 7 is 14, double 14 is 28, double 28 is 56, repeated doubling. When your children get to division, we use repeated halving to divide by 8, to divide by 4, or to divide by 2. So the strategy works both directions. Here are our square numbers. So we have a 1 by 1, a 2 by 2, a 3 by 3, and so on. These link to those facts. And again, your children tend to remember these square numbers easier than other facts. The imagery is very strong, and they see the 10 by 10 quite a bit because it's one of the base 10 models that they're also using in addition and early multiplication. So place value ideas, 10 by 10. So think about all the facts. These are facts, fact tables many of us learned, and think about the strategies we've done so far. We looked at the zeros through story. We did 0 groups of 1 and 0 groups of 5 and got your child giggling about that as they're putting nothing on their paper. We also did 1 group of 0 or 8 groups of 0 and what that would look like. We took care of the ones through story, 1 group of 1 or 1 group of 6, and the turnaround facts, 2 groups. And through that, we learn about the multiplicative identity. What happens when you multiply by 1? We did the 10s, a group of 10, 4 groups of 10, 8 groups of 10. Took care of those, and through the turnaround, that takes care of our 10s facts. We looked at 9s as building down. If you know that 3 groups of 10 is 30, 3 groups of 9 is 3 less than that, 27. If 8 groups of 10 is 80, 8 groups of 9 is 8 less than that, 8 fewer than that, 72. And we have the turnarounds. Now, we also looked at 5s as half of the 10s. If 3 10s is 30, 3 5s is half of that, 15. We took care of the turnarounds with the 5s. Now notice halving is a lot faster than skip counting by 5s. It's a more efficient strategy. So I could have skip counted by 5s, and we do that quite a bit. You'll see this, but I want strategies that become more and more efficient and also work beyond the facts, right? Now, we did doubling, and that takes care with the turnaround facts of those. Double doubles, right? Using repeated doublings to do the 4s and doing repeated doubling again to get the 8s. Or we can do the build down for the 8s also. We looked at different strategies for that. And then we have our square numbers, the 3 by 3s, the 4 by 4s, the 7 by 7s. Now, at this point, I'll put in bold the facts, but these are the facts that we haven't addressed. So a lot of people say, well, you did all these strategies, but you didn't do anything with the 3s, the 6s, and the 7s. Well, we did through all the other strategies and using commutative property, the turnaround link, okay? So we've got these facts that are left. Now, just let's think about 6 3s. See, 6 by 3 is double the 3 by 3. So if you know 3 by 3 is 9, then you know 6 by 3 is double that, 18. And if you know what 6 by 3 is, then you know what 3 by 6 is, commutative property. So that takes care of those facts. 3 times 7, we've looked at this equal grouping chart and the distributive property before. I can think of it as 3 5s put together with 3 2s, right? I can slide those down, 3 5s put together with 3 2s. That's one way I could do it. Some folks, that's just one fact to memorize. So I can use distributive property, or I learn that 3 times 7 is 21. If I know 3 by 7 is 21, then I know 7 by 3 is 21. Commutative property. That takes care of that. And the nice thing about 6 times 7 is once you know 3 times 7, it's the double. So if 3 times 7 is 21, 6 times 7 is double that, 42, and the turnaround fact. So in those cases, we actually have all those facts. We were left with 6 on our chart that we didn't get with the strategies, but we again used doubling to our advantage and double square numbers or double a fact that we know to get the other facts. The strategies, as I keep saying, help your child move beyond the fact. If I know 0 groups of 8 is 0, I can do 0 groups of 8,964 or 1,897,452, or this binomial down there. And I know some of your kids, they get so focused on when I see a binomial I'm supposed to square, I need to expand that, and they lose sight of the 0. See, I can put something as nasty as I want there, and as long as I group it and multiply by 0, the answer is 0. And that's the understanding we want your child to have. They can go far beyond because they know what happens when you multiply by 0. And the same is true when you multiply by 1, right? 1 times anything, it's the multiplicative identity. It just leaves that identity there. The 9s we build down, right? I can do things more mentally because if I know 8 times 9 is 8 times 10, remove 8, well, that's great. What would 98 times 9 be? Well, I'm going to do 98 times 10, remove 98. Well, 98 times 10 is 980. To remove 98, I would remove 100 and give back 2. Here's our addition strategies coming back into play. 880 plus 2, 882. See, I get to be more playful with numbers and be much more successful and fluent with strategies, with mental arithmetic when I know the strategies, not just the facts. So again, we want to know both. Same is true with having, right? My 8 times 5 is half of 80. Great. What's 88 times 5? Well, it will be half of 880, 440. So when you're working with your child and you have these flashcards, whether they're written horizontally or vertically, and you flash them, if the first thing your child says is 0, on this one, we're practicing fact fluency. They're just telling us 0, 63, 18. That's fact fluency. If we change it a little bit and we have them first describe what they see or use a strategy, that will build both fact fluency and strategy fluency. So here I have 0 groups of 9, 0. 9 groups of 0, 0. Or they tell a story, 9 groups of 0 cookies. 7 groups of 9, well, that's 7, 10, 70 minus 7, 63. So I can use the strategy. Double 9 is 18. Double 7 is 14. Double 14 is 24. See how I'm using 28. See how I'm using the repeated doubling. 8 sixes. Well, double 6 is 12. Double 12 is 24. Double 24 is 48. So I can use that repeated doubling. 7 tens is 70. Half of that is 35. So you see how I'm using the strategy to tell the fact. So sometimes you may want to go through and practice fact fluency. But you also want to have them practice strategy fluency because that gets us beyond the facts. So, to help your child be very successful with multiplication and remembering their facts, we want to be purposeful in the order in which we do it and how we work with your child on the facts. We can start with the zeros, the ones, and the tens. Know that the distributive property will let us build down to do the nines. We can use half of the tens to do the fives. We use repeated doubling, and as I said, when they get to division, they use repeated halving with the twos, fours, and eights. Square numbers, which links to the area that they will be learning and usually introduced to in grade 3, and the distributive property throughout. If this video was helpful, I hope you found it to be helpful. I hope you will please give it a thumbs up. Please subscribe to the channel so you know when other videos are available. And thanks so much for watching.